Good afternoon. Hello everyone. This is group number 37. We're going to be pitching to you our idea about our project. It's about multimodal EEG signal processing with body microexpressions for driver cognitive risk perception using knowledge distillation. So I'll start with presenting to you the problem we're trying to solve with our project and by setting up problem statement. So worldwide, most accidents and data has showed that over 94% of accidents is caused by human error. And in Uganda alone, road accidents statistically cause or attribute more deaths are attributed to road accidents than malaria and HIV combined. So there have been driver monitoring systems that have been created to mitigate these kind of errors, but the primary or the traditional ones depend on eye tracking and vehicle telemetry using the cameras that are mounted on the dashboard of the vehicle. So this limits accuracy in low light conditions and it has delayed responses. So these systems also fail to detect the cognitive state of the drivers or understand things like emotion distress, things like fatigue, things like drowsiness. They are very inaccurate in such scenarios. So there has been a pressing need for an AI-powered multimodal system that can predict the cognitive states or the driver's cognitive risks in real time. So that's the kind of problem we're trying to solve. And our project objectives are to develop an AI-powered driver cognitive risk perception. As I said, something that can access the human brain and understand risks at a cognitive level. We have also had a need to develop something that can enhance the monitoring systems that have been existing. So build on top of what is already existing, build on top of the camera-based models that are already existing, and then predict any driver risks before the symptoms can even appear by accessing, as I say, the human brain. So we also want to provide real-time warning to drivers that are customed depending on the current conditions of the driver and the environment around them. So our solution overview, we came up with a solution where we can use wearable EEG headsets to be able to access the cognitive state of the drivers. So we access the cognitive state of the drivers by reading the EEG brainwave functions and be able to assess the cognitive impairments like stress, distraction, drowsiness, fatigue. We also additionally we add on top of the already existing traditional systems and use the cameras to also detect other kinds of behaviors, other kind of risky behaviors like distraction, talking on phone, and maybe also drowsiness to increase on the accuracy of our system. So we combine both this data, these systems, these models in form of a multimodal to make something that is more accurate and dependable to the drivers. So then we deploy this to be able to pass on, as I said, warning alert depending on the kind of environment or the kind of state of the drivers, so customizable. So on training our models, we use the seed data set, which is an EEG signal for facial expressions and driver impairedness. Then we also use the multi-class driver image data set, which captures the images or captures the visual conditions of the drivers. Moving on, the models we use the image for image classification, we use the vision transformer, and for the EEG signal processing, we use the convolutional neural network for EEG analysis. We chose these because we trained a couple of models on both data sets. For the image data, we trained the vision transformer and the CNN, and we discovered that the vision transformer works better and we want something with more accuracy because this is a life and death matter. Then for EEG data, we trained the ensemble, we trained the gradient boost machine, we trained the KNN, linear regression, random forest, support vector machines, and SG boost. But we realized that the CNN outperformed all of them with an accuracy of 88%, and that's what we chose. That's what we chose for our model. So for our system architecture, we're able to our data runs through a system pipeline that starts with data collection through the EEG headsets. So we collect the EEG signals and the image data that is captured by cameras on the dashboard. We pre-process this data. Then we pass it through feature extractions and classification to identify which features are more important. Then we make the decisions and fuse the decisions of both models for better accuracy, and then we deploy it we deploy this and be able to get the alerts or the predictions of our models. So that's a diagram to represent the system architecture. Then moving on, I'll talk about the system implementation, how we plan on implementing our system or our model. So we have the software implementation, where we use libraries like PyTorch, MATLAB, and OpenCV. Then we host our system in the web in the cloud using the Amazon Web Services, and then we have it running locally or natively on our hardware that is built into the car. And this kind of hardware we're planning to employ the NVIDIA Jetson series and use the EEG headset. We want to use the Muse 2, and also use some camera, any camera that is low budget and can be able to capture infrared for better accuracy. We have a video that shows the demonstration of how our system works. It's on YouTube on that link, and then my colleague will come in later to demonstrate how it works. So the intellectual property, we have a potential intellectual property where we have the EEG signal processing, we have facial microexpression algorithm, and the combined correlative risk detection algorithm. We have our processes that we use in our models, like the real-time driver monitoring process. So those are our intellectual properties. Patentability, yes, our system has potential for patentability due to its novel and new techniques that haven't been yet used in the industry. Our code that we use in our system is copyrightable, and our trade assets and our trademark, which is our name, are also protectable by the law. We have the monetization, how we can better generate money or revenue from our system, and we have different revenue generation or commercialization avenues. We have the OEM, or the original equipment manufacturing integration and partnerships, where I can collaborate with already existing manufacturers like BMW, Benz, people that have already had these advanced driver assistance systems, their vehicles, to build on top of that and partner with them. We also could partner with suppliers to retrofit these solutions in already existing cars that have already been bought off market. You could also partner with fleet and insurance companies, where we can work with fleet companies or transportation companies to have this system implemented in their vehicles to monitor their drivers and assess their driving conditions. Then you could also partner with insurance companies to implement this as an insurance policy in some of their insurance policies. Also subscription-based models where we can charge based on our software, and then licensing also our technology to other people that are trying to implement them in their technologies as well. Then we have the potential market size, which the global ADAS market is projected to exceed over 60 billion in the coming years. So that could be a potential growth for our system. We have, as I said, commercial fleets and insurance companies, which are growing sectors. Then the aftermarket segment, aftermarket and commercial segments, by retrofitting these in other systems. So I'm going to invite my colleague to talk about the impact and relevance of our system.
Hi everyone, my name is Segnia Isaac, and I'm going to be taking you through the impact and the relevance of our project. So this project addresses the growing concerns about the road safety and the driver empowerment, focusing on the increasing accidents caused by the human error. So these human errors, as my colleague told you, we have fatigue, the distraction. So by utilizing these advanced technologies like the EEG signal processing and the facial microexpression, we are developing a proactive system for the real-time monitoring for the driver state. So the impact of our project, I can give it in an aspect of it has like it's going to give an immediate effect to the society, as it will reduce the road accidents compared to the other projects which have been around. But yeah, so this approach enables early detection of the cognitive risks, so therefore reducing the driver impairedness. So to move on to the sustainable business model, we have a commercial profitability and the value proposition. So it reduces the road accidents, lowers insurance claims, then targets the OEMs, the original equipment manufacturers, then generates revenue, then the long-term success and adaptability. The modular design is future proof, like the AI, VGA, Jetson, and so on. Then dependable, sustainable resource use, energy and efficiency. Then giving back and the social impact, like I've told you, it gives you an immediate impact of reducing road accidents. To move on to SWOT has the strength, innovative, weakness and opportunities. My colleague is going to take you through this.
So for the SWOT analysis, we have our strengths, weaknesses, opportunities, and threats that our project is faced with. So our strength, first of all, we have innovativeness of our idea because I said it's novel and a bit new in the industry. We have the real-time adaptive alerts, which have also not been seen in the industry. So that is a strength. And then our scalable model, as my colleague has said, our modular design enables our project to be scalable to bigger markets. Then we have the weaknesses of our system. So the high development costs and integration costs, because this technology, most of these sensors are going to be very expensive, and initial cost of setting up business is really expensive. This is hard technology that we're talking about. The user acceptability, because of privacy concerns, of course, could also be a weakness. Then opportunities. So growing concern or growing demand for safety technologies is an opportunity. The technological advancements that the world has seen in the previous years, like AI algorithms and edge computing and computer vision. And then expanding market segments are also opportunities, as I said, to expand to other parts of the world. Then we have the threats that we face, like established competitors, of course, would want to come in and try to tackle us. Then we have the regulatory hurdles, so strict regulatory restrictions by the governments. Then maybe technological disruptions, so this could pose a threat, as I said. We have a budget of 9.5 Ugandan million shillings to set up a minimum viable product or something that can help us move on to other stages of other stages of our project. Then future work, we want to extend our system. So what we plan to do in the future, we want to extend our system to have cameras on the external part of the vehicle to monitor the environment, so that we can also be able to adapt to adapt based on the environment. Maybe you're in traffic, you're in low light, you need different light, different amounts or different levels of attentiveness. So this could help our system better adapt to the external conditions or environments. Then we want to also implement NLPs and large language models to make our alerts more conversational and natural and customized to each and every individual. Then we are planning to also share this kind of information between vehicles to help drivers better plan for their road safety through a technological vehicle-to-vehicle communication. Our team contributions, Segunya Isaac is the CEO and Operations Manager, and I'm the CTO and the Chief Operations Officer. The lessons learned is that we have learned a lot of different technologies while building this. We have learned agile collaborations because this has been a very collaborative project, and working on it together has helped us build our collaborative skills. It has helped us understand the importance of early data validation because this model highly rely on data, and then it has helped us build understand scalability and adaptability because we're building our model to be as scalable as possible. The challenges are that data integration and synchronization, since each EEG signal is kind of dependent on its provider. Different people have different EEG or brainwave functions. Real-time processing is a constraint because it's expensive, because we need edge devices that can prove to be expensive. Then noise and artifact management. AG signals are very noisy, and it gave us a challenge in pre-processing for our models. Then, in conclusion, our project has achieved a lot of significant milestones, and it's novel and it's new and it has a lot of potential due to its advanced detection techniques that have been built, our successful integration of EEG and facial microexpressions, the real-time processing which could be provided by edge computers is also an advantage and a great achievement. Our scalable architecture for bigger markets, as I said, and our interdisciplinary collaboration techniques that we have used in developing this project. So our system not only enhances driver safety by providing proactive alerts, but also paves the way for a evolutionary interconnected transport ecosystem that could be novel. So with our cutting edge fusion of EEG, facial microexpression, and environmental sensing, we are setting a new standard for real-time intelligent driver monitoring. So your investment will accelerate this transformative technology drastically to reduce road accidents and redefine the future of automotive safety. Thank you very much. This was group number 37, and we hope to hear back from you.